Regression analysis is useful in predicting the expected values of one or more dependent variables with respect to an independent variable. It can be a simple yet effective tool in data analysis and has very useful applications from an engineering standpoint. Let's suppose that a certain company is testing the relationship between the distance apart on the axles of a car and the strength of the undercarriage unit to support the weight of that car. The first equation, y equals mx plus b, is the basic equation of a line and something we all know. It is very similar to the regression equation below it. Beta represents the increase of the dependent variable for every increase in the independent variable, and alpha represents the y-intercept. In the next slide, we'll see that this is the actual equation of the regression line used. The last equation here adds another term epsilon that accounts for the error of the regression line. This just says that there is a vertical deviation between the line and the actual values of y. This is the equation used to find the true value of y. Back to the engineering company testing the relationship between distance and weight. On the right is a graph of the distance between axles on the x-axis and the strength needed to support that weight on the y-axis. The regression line shown is running through the dataset and shows a linear estimation of their relationship. Using the least squared method, the line is created to reduce the vertical deviation squared from the line to make an accurate representation of the data. The parameters alpha and beta are what define the regression line, while sigma squared signifies the variance of the errors around that line. These three parameters comprise the regression line. The alpha parameter is equal to the y-intercept, which is about 2.7. The beta parameter is equal to the amount that the weight supported is increasing as 1 meter of distance is added, which is about 0.37. The sigma squared parameter is equal to 0.75, which represents the variation of the error around the regression line. This is calculated by adding the sum of squares of the error and the sum of squares of the regression line to give you an estimation of the sigma squared parameter. The engineering firm responsible for finding the relationships could use this data to plan ahead and decide on the right distance and weight supports they need in making vehicles. It is also wise to note that in estimating these parameters, the true values of these parameters are not found but only estimated, meaning more data and analysis could yield more accurate results when testing. But in the real-world scenario, these parameters may actually be never known. Thank you for watching this video on estimating regression parameters.